Now in this video, we want to look at a very important rule, okay, that helps us a lot in evaluating limits of functions. So this is a sandwich theorem, or we can also call it the squeeze theorem. So it talks about having three functions, okay, and then having a particular function which you want to find the limit of, lying in between the other two functions. All right, so if you can find the limit of these two extreme functions and they give you the same result, right? If the limit of this one and the limit of this one are the same, then that result is the same thing that you would get when you find the limit of the function lying in between the other two limits. So it states as follows, that suppose f, g, and h are functions of x, all right, such that g of x is less than or equal to f of x, and f of x is in turn less than or equal to h of x, so f of x is sandwiched between g of x and h of x, right? Good. And we have that the limit of this g of x, that is the extreme left function, and the limit of the extreme right function h of x, the limit of those as x approaches some value c, the limit of those two, okay, are the same and gives us a real number L, then what that tells us is that the limit of this middle function as x approaches that same value, c, is going to give us that same result, which is L. So you have f of x lying between two functions, right? Bigger than this one and less than this one. But this and this are the same. Their limits are the same. Then this one, the limit of this one also be the same. That's just it, right? Good. Let's apply this limit and solve this very nice function. X times sine of 1 over x. All right, good. So to find the limit of the function, this sandwich term will be very, very nice, or will be very, very necessary. Now, here's a fact that we know. We know that sine of an angle, the biggest it can be, okay, is 1. And the least it can be is minus 1. This is it. If we have sine of an angle, right? Sine of an angle, let's call that angle theta. Okay, it is less than or equal to 1. So if you take the sine of any angle, the result cannot be more than 1. No matter how big the angle is, the result cannot be more than 1. Because this place here, the coefficient there is just 1. And this is in turn bigger than or equal to negative 1. See, there's no angle whose sine will give us a result less than negative 1. So the result of sine of angles lie between negative 1 and 1, with negative 1 and 1 included. Good. Since we know about that fact, that will give us that any angle at all, sine of any angle, lies between negative 1 and 1. Good. In this case, observe that our angle here is 1 over x. This theta is just for any arbitrary angle we can have. Okay, so let me just put that down. This is just a fact that we know, right? So let's do this. We say that sine of 1 over x will lie between 1 and negative 1, because we say where theta is any angle, right? So in this case, the angle there is 1 over x. Good. Now, observe that this function has x being multiplied with it, all right? So to make use of the sandwich theorem, we've gotten inequalities here where the extreme left and the extreme right are negative 1 and 1 respectively. So to get the x together with the sine 1 over x, we need to multiply through by x, all right? So we multiply through by x, we're going to have negative x, that is x times negative 1 gives us negative x, times is less than or equal to x times sine of 1 over x, right? Which is less than or equal to, we multiply 1 with x and we get back x. Good. Now that we've gotten the main function in between other two functions, all right, we want to make use of the sandwich theorem. Now, this sandwich theorem tells us that if we can take the limit of these two extreme functions, take the limit of this one and take the limit of this one, if it gives us the same value, okay, as we approach the value, the point of interest. So let's look at it. We take the limit of the extreme left, which is the limit of minus x or negative x as x approaches 0. All right? Good. And then we will also have to take the limit of this other one, this x, there's the identity function, as x approaches still the same thing, 0. So let's see what we've got. As x approaches 0, right? As x approaches 0, negative x will be what? Well, 0, negative 0 is the same thing as 0. So as x approaches 0, this limit gives us 0. Because we're talking about limit of negative x. As x approaches 0, it's going to be negative, let's say negative 1 times 0, which is just 0, right? Again, let's look at this other function. Limit of x, these are the identity function. As x approaches 0, this one is simple. It will just be 0. So, the extreme left-hand side, okay, the extreme functions, the limits of the extreme functions are the same, 0, 0, right? So that tells us, okay, that the limit of this middle function, x times sine of 1 over x, as x tends to 0, will be equal to 0 because it is sandwiched between these two functions whose limits, they are both zeros. So the limit of the middle function is going to be 0. Okay, great. All right. So you see the way we went through the fact that we know, and then we use that to generate the function. All right. Thanks for watching. Please subscribe to my channel.